Hey guys, this is the third week of online school, and Sunday we have no class, and so this is the first video of this week. We are going to go through chapter 9.4, and I divided this section into two so that we can focus more on the vertical and horizontal asymptotes today, and then tomorrow we're going to focus on oblique asymptote and a point discontinuity. So I know I'm throwing out new words to you guys, and so let's look at this together and see, see how it is. So unlike the functions that we've seen in section 3, now in section 4, the functions that you're dealing with has numerator and denominator with polynomial expression. What that means is that you can write it as functions on the numerator and then a denominator. And so a rational function is basically function divided by another function. So to graph this by hand, we need some clues. We can't just graph it like linear function or quadratic function. This is quite different. So the clues that we will get is a vertical asymptote. So it's the line that goes vertically that we never crosses, or we get closer to. Okay, that's a better definition to remember. And a horizontal asymptote that goes horizontally, and then the line gets closer to. Oblique or slant asymptote is an asymptote that is kind of not vertical or horizontal, it goes slant like this. Okay, so it looks like a linear function. Holes, which is also called point discontinuity or removable discontinuity. So if I use the word interchangeably, please know that it's what I'm referring to, holes, removable, or a point discontinuity. And those are the points in a function. So let's say I have a function like this, that it's missing a point like that. So on a graph, you will see a little open circle. And actually, you won't see an open circle if you use the graphing calculator. And even the asymptotes, if you just use a graphing calculator, you are going to see very strange looking function. That is why, even though you have a technology that can graph it for you, you have to conceptually understand how to graph this so that when you are looking at your graphing calculator as an aid, that you don't totally trust blindly, but like you can use your critical thinking ability to know what the graph is actually showing you. Okay? So today we're only going to focus on vertical asymptote and horizontal asymptote. And vertical asymptote is very easy. As we already practiced finding them in the last section, you need to make sure that the denominator doesn't equal 0, because where it equals 0 is where the asymptote is. Okay? So then, when you look at a problem, you don't even need to consider what's happening in the numerator. All you need to look at is the denominator. And then you set it equal to 0 and solve for x. X equal 1 is your vertical asymptote, and I will often write it as VA. Okay, so then let's look at the next one. Again, I know it looks very complicated, but all we need is a vertical asymptote right now, so you only look at the denominator because we want to make sure that the denominator doesn't equal 0, so that my vertical asymptote is x equal -1. Last one. Again, we are only looking at the denominator because we are looking for vertical asymptote. So x plus 2 squared is equal to 0. Well, we have to square root both sides. So it's x plus 2 is equal to 0 because square root of 0 is 0. And minus 2. So x equal -2 is my vertical asymptote. So that was the easy part. Okay? So vertical asymptote, just like the last section, is the same. You are setting the denominator equal to 0, and whatever the x value you get is where the vertical asymptote goes through. Horizontal asymptote, though, is a little bit more complicated because there is a rule that you need to remember, okay? So I'm going to explain to you. To find a horizontal asymptote, you need to look at both the numerator and denominator at the same time. And what you're looking at is not the number itself, but you're looking at degree. So from the polynomial chapter, if you remember what degree is the highest power in the expression. Okay, so let me review that. So what is the degree of numerator? Well, it's x cubed, and 3 is the highest power. Therefore, the degree of the numerator is 3. And then the denominator, it's x to the 1 power, right? So my degree is 1. Once you have figured out what the degree is for both numerator and denominator, you need to think about 3 things. Well, there are 3 scenarios. Okay, so first case is the degree of the numerator is greater than the degree of denominator. And the second case is degree of numerator is equal to degree of denominator. And the third case is degree of numerator is less than degree of denominator. So the example is a first case, right? Because my numerator degree is greater than denominator. And so my case for this one is A. So what that means is that whenever your numerator degree is greater than the denominator, you have no horizontal asymptote. Okay? So you will just write does not exist. We're actually going to look at the second one later. The third scenario, which was when the numerator degree is less than the denominator degree, then you always have y equals 0 as your horizontal asymptote, meaning your x-axis is your horizontal asymptote. And you know this is true because think about our function y equal 1 over x. Where were my horizontal asymptote? Well, it was here, right? And then actually this was a horizontal asymptote too, and it went like this. And the only time the horizontal asymptote changed was when you had like +1 and +2 and things like that, right? So from your very basic rational function, you can remember, okay, when the numerator has a lesser degree than the denominator, then my horizontal asymptote is always x-axis, which is y equals 0. And when the numerator is greater than the denominator degree, then there is no horizontal asymptote. So the second scenario is the one that you need to remember. And it's very interesting, okay? So when your numerator and the denominator has the same power, look at this example, they both have a degree of 1, so they're equal. So then what is my horizontal asymptote? Well, you need to first look at the leading coefficient. Remember, the coefficient is the number that comes in front of the variable, but leading coefficient is the number that comes in front of the highest power. So here, the leading coefficient is 2 for the numerator, and then leading coefficient is 1 for the denominator, and that is your horizontal asymptote, which is, I write it as HA. So y equal 2 is your horizontal asymptote. Okay, so let's look at more examples, because this one you just have to get used to it. All right, so let's now find horizontal asymptote of each example. First, we need to compare the degree. The degree of a numerator is 3, and the degree of the denominator is 1. So then numerator is greater, so it means no horizontal asymptote. Okay, it was a case, first case. Second, again, the degree of the numerator is 2, and then degree of the denominator is 1, so it's greater, numerator is greater, so no horizontal asymptote. It's easy. Again, this one you might be thinking, how do I know my degree? This is kind of review from the polynomial function chapter. We know without foiling that the highest power for the numerator will be x cubed, right? Because when I foil, I'll foil 3 times, so then I'll have x cubed as a power. I don't know what the other thing is, but I don't care because I only care about the degree, okay? And then same thing, if you foil, I don't know what the actual FOIL product is, but I know that the highest power will be x squared because you have x plus 2 times x plus 2. And on top, it will be x plus 1 times x plus 1 times x plus 1. So then, numerator is again greater than the denominator, so there is no horizontal asymptote. Okay, so hope you remember, whenever the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Okay, let's look at these three. Sorry, I have yet another example that they are exactly the same, right? Because same as, like, there is no horizontal asymptote. Because the degree of the denominator is less than the degree of the numerator. So finally, we have something different here. Now they are the same, right? The degree is the same because they're both 1. So then remember, you have to look at the leading coefficient, and the leading coefficient of the numerator is 1, and then the leading coefficient of the denominator is also 1. So y equal 1 is your horizontal asymptote. Finally something different, yeah? Okay. Last example. Okay, this one, you might be just say, oh, they are the same because I only see the power of 111, but you need to remember, this one, right, the degree is 1 because it's just 2x. But think about the second one, it's x plus 2 times x minus 5. So when you FOIL, the highest power you're going to get is x squared, meaning that your degree of the denominator is actually 2. So then this is a case where you just automatically get y equals 0 as your horizontal asymptote. Okay? All right. Let's go to the last one. So the reason we are looking at all these things is so that we can actually graph it, but just having those asymptotes give you a good guideline, but it doesn't actually tell you what your graph looks like or anything like that. So to make it a little bit more accurate of how you graph, you can find zeros, which is x-intercepts, and you can also find y-intercepts. So I'm going to show you as an example of graphing this by hand. Okay, it's just a rough sketch. Okay. To find the x-intercept, what you do is that you set the numerator equal to 0 because 0 divided by any number is always 0. So we are using that idea. So x to the 4th power minus 6 equals 0 to find x-intercept. So then I know that this is a squared minus b squared. I told you to remember this factoring always. It's a plus b times a minus b. So then this one is x squared minus 4, x squared plus 4. Okay? But then x squared minus 4 is still something that I can change it to x minus 2, x plus 2, and this has to equal 0. So that means x minus 2 is equal to 0, x plus 2 is equal to 0, and x squared plus 4 is equal to 0, but this is impossible with the real numbers. I'm not going to deal with that. So my 0 is 2, 0, and negative 2, 0, and they come from here. Okay? So now that we found the x-intercept, let's try to look for y-intercept. And y-intercept, you find it by plug 0 into x. So I'm going to do that. 0 minus 16 and 0 minus 1. Negative 16 divided by negative 1 is 16. So my y-intercept is 0, 16. Okay, so I have 3 points, which is very helpful. Now let's look for vertical asymptote. Okay, vertical asymptote is found by setting the denominator equal to 0. So let's do that. X squared is equal to 1. X is plus minus 1. Why is it plus minus? Because when you take a square root, it's always plus minus. So I have 2 vertical asymptotes, x equal 1 and x equal negative 1. And the horizontal asymptote, well, we know there isn't one because the power, the degree of the numerator is greater than the degree of the denominator. So if I roughly sketch this, I don't have much time, so forgive me. Somewhere 16, and then 2, and 2. I think it looks I don't know exactly, but it will look